Hello, all my dear friends and everyone watching. I hope you're all doing well in these difficult and challenging times. This video is the video following the previous one, which was the introduction to force. And in this video, we're going to take a further look on different types of forces that we didn't cover in the previous video. And those would include we covered the gravitational force, frictional force, tension, and electric force, but what we didn't cover was the magnetic force, and we also didn't cover the nuclear force. So magnetic force would be the force that acts between magnets, and the nuclear force would be the force that acts inside the nucleus of an atom. The nuclear force has actually two types, the strong force and the weak force. We'll cover both in this video as the independent and different types of forces. Looking at the magnetic force, the first question is, well, what is it? And the magnetic force is actually one of the simplest to answer, as you've likely seen it in effect as a kid. Kids usually assume magnets to be magic, they just stick to each other. But there's actually a key force in play here. And if you look at the word magnetic force, you'll actually see what I mean. The word is self-explanatory. It's the force which acts on magnets, or any magnetic body or ferromagnetic substance for that matter. Now, any magnets, when they're in proximity of one another, they experience a force, and this is due to the force field present around these magnets or magnetic bodies. The field flows from north to south on the outside, but actually on the inside, it's flowing from south to north, forming a circular loop. The field is strongest near the poles and weakest near the center of the magnet. If we look at a simple bar magnet with two poles, you'll see that if you cut it in half, both magnets still retain the north and south poles. And this is the same if you cut it once again, making them into four pieces. They'll all have their own north and south poles. And you can actually do this forever. You can keep cutting magnets and you will always have two poles in all the magnets, a north pole and a south pole. This shows us that there cannot exist a monopole magnet. So magnets, in other words, basically, magnets are always dipolar. So what is a monopole magnet? Well, it's a magnet with only one pole. Pretty simple, because the word mono means one. So you can't have a magnet with one pole. That's basically what it's trying to say. If we now, one more thing is if we put iron fillings or iron particles around the magnet, as you're seeing I'm doing here, then the particles align themselves with the field. And those dots are just basically iron particles. So they'll align themselves with the direction of the field, and this will actually help us know the direction of the field. Now let's look at the nuclear force, or nuclear forces, because there are two of them, which play inside the nucleus of an atom. So let's take the structure of an atom. And now let's look at the nucleus. The nucleus has two particles. There's the proton, which is positively charged, and there's the neutron, which is negatively charged. Now, the proton actually experiences an electric force. Because the proton is positively charged, the electric force tries to repel protons because they're the same charge. But the question we should ask is, why then do the protons stay together? They should be flying apart at racing speeds. So we'll look at the proton because the neutron doesn't have any charge. And the answer is that there's a strong nuclear force in effect, which makes the protons and the neutrons stick to each other. The strong nuclear force acts at very, very small distances, such as those inside a nucleus. So if we take a nucleus, okay, it's a simple nucleus with protons and neutrons arranged fairly evenly. Usually the neutrons are more than the protons, but anyway. If we take this nucleus and we look at the forces playing between the protons, we'll see that there's the strong force, there's gravity, both pulling together, but there's the electric force trying to repel the protons. We'll ignore gravity for now because gravity is very weak in comparison to the other two forces. The strong force is actually much stronger than the electric force. It's actually 100 times stronger, roughly, which is why the strong force wins and makes the particles stick together. Now we'll look at the weak force. The weak force acts on particles that we call leptons. Now leptons are very light and roughly massless particles. They do have some mass, but they're almost massless, especially in comparison to their hadron counterparts, which are like protons and neutrons, much heavier. So what are some examples of leptons? Well, examples would include the electron, muons, tau particles, as well as their respective neutrinos. The most common one you'll probably be familiar with is the electron. Now we'll take a look at what the weak force actually does and what it's actually responsible for and where we can see this force in effect. So the weak force is actually responsible for radioactive decay, or rather certain types of radioactive decay. Those decays involving beta particles or any leptons or like neutrinos and so forth, where small particles are ejected from the atom. So if you have an atom and you have an electron being ejected, then that's radioactive decay. That's beta minus decay. And the force responsible here, or the force responsible for the interaction, would be the weak force. Now, throughout this video, and if you consider the other videos, we've covered the 4 fundamental forces. These forces are as follows. The gravitational force, which is basically the force that causes attraction between masses. It's important to note that the gravitational force is never repulsive, it always attracts. So for example, you standing on the earth and you experiencing your own weight is an example of you feeling the gravitational force of attraction of the earth present upon you. We also covered the electromagnetic force, and if you're not a bit clear, it's because the electric force and magnetic force can be combined into a single force, the electromagnetic force, and we covered both the electric force and the magnetic force. We covered the strong force, which binds the nucleus together and the particles in the nucleus, and we covered the weak force, which is responsible for radioactive or certain types of radioactive decay. And basically these 4 forces comprise the 4 fundamental forces in physics. So thank you very much for watching once again, and I hope you have an excellent day and look forward to the next video.